Pilot teachers and students, good morning, class. Good morning, sir. Okay, thank you, Miss Shin. All right. In our last lesson, we had a look at one type of force which is known as the upthrust, and upthrusts are the force that is exerted by liquids and also gases. Now, in this lesson, we'll be basically going through and then looking at another type of force which is known as the surface tension. Now, when you were studying chemistry, you should have seen the behavior of particles, or let's say molecules or atoms in each one of those. For example, in a solid, right, the particles will be, they will have to take, or they have a definite form or shape, and they are in a fixed position. But in a liquid, you find that these particles will be a bit further apart from each other, and in cases, right, they will be more, or let's say, far apart from each other. Now, the question is, what is surface tension? I will give you some time to quickly go through that, and then I'd like to have answer or your definition of surface tension. All right, we'll have your answers now. Sulaiman, what is your explanation of surface tension?
Surface tension is sort of like a property of water or liquids, whereby if it acts like a skin, so if you put something on it that's less denser than the water, it will float on the top. If it's more denser, it sinks.
Very good explanation. Now, surface tension is simply the property of a substance that acts like an elastic membrane, or simply when it acts like a stretchy skin. Right, let's have a look at this one, the definition of surface tension. Now, if you can see, right, the surface force or surface tension is a force of attraction between molecules on surfaces of liquids. I will give you this next information. All right, you'll find that there is a tension because the molecules on the surface of okay, they are slightly apart or further apart. The molecules in a straight elastic band, or they form like a straight elastic band. Now the tension tries to reduce this surface area. Okay, moving on to the next. All right, you will find that the force of attraction between the molecules of the same substance is called cohesion, or it is sometimes known as cohesive forces. Now, example can be seen, or let's say a force that holds raindrops together. That is an example of a cohesive force. I have finished. We will now go on to the next piece of information, and that is on the force of attraction between the molecules of different substances called the adhesion. And you find that in examples like glue, or let's say paint to the wall. So that is an adhesive force. Okay, there are different substances, since paint and glue are different substances, and the wall also has different particles. So we can see there is an adhesive force. Okay, cohesive meaning particles of the same type, but in adhesive forces you find that there are different particles of different substance. shall we move on to the next? All right, the activity for today will be simply you have the glass of water that has been filled, beakers are there, you have razor plates there. Right, what you can do is carefully float that razor plate on the surface of the liquid and then describe what you see. Okay, what can you explain from that little experiment? Okay, float that razor plate. You are given each one of those. Simply put into the beaker and then you pass it around. Okay, just pass it around to have a look at it. All right, that is the first part of the first and the second activity. Now the third one, right, use capillary tubes of different sizes. That is what I have here. Okay, I've colored the water to show you so you can pass this one around and then have a look at how the water is rising in these capillaries. Okay, you have to just take it out, take the two, and then you compare which one the liquid is rising faster, and then you can explain in terms of adhesive and cohesive forces. All right, while you are passing that around, one example that you can see is especially on if you are measuring anything, let's say of a liquid, let's say water, if you have to measure that using a measuring cylinder, or let's say in a test tube, you will find that there is something which is formed. A meniscus is formed in a liquid when you're trying to measure. Right? That is something like this. Right, this is a meniscus when you are trying to measure the liquid. volume of the liquid, but you find that it forms a meniscus. Why does this happen? Right? Why does it happen? I'll give you a few more minutes to quickly go through the, right, and write down what you observe from those activity. And I will be asking for your explanation from those. Okay, here. You can also pass this one around and then see where the water is forming something like a meniscus. Okay, why does it form that? right, we will now go through the correction to those activity questions. You have two activity questions. Question number 1 is a razor plate which was being placed on the surface of the liquid, and number 2 is on the capillary rise. There are two different capillaries that are being used with a colored liquid. All right, we'll start with question number 1. Okay, Nathaniel, from your observation for the first activity, okay, how can you explain that? Or what is your explanation? By floating that razor on the surface of the liquid, right, you can stand up now. All right, give your explanation. Quickly stand up. You explained or explain your observations, and then you can sit down. All right, Joseph, you help him. What is your observation from that razor plate and the liquid? Okay, Nathaniel will come to you for the second question. Okay, you will come back, or you will have to answer the second question. Okay, Joseph. Okay, that is for activity number 1. Carefully float a razor or needle on water, and then you explain.
The razor blade floats on top of the water. This is because the weight of the displaced water equals the weight of the razor blade.
All right, you can sit now. Who has other explanation for that observation? Okay, we will have Michael, you tell us what you observe from that.
The razor floats because of the force of attraction, adhesion between the molecules of water and the razor.
Okay. So, very good. Okay, looking at yours, We are going through surface tension, and you had a look at this as the force that attracts molecules together. But when you flow that razor, it is quite light, it cannot sink. But you will find that the water was rising up even if, if it has to form something like a stretchy skin, okay? Just like, right, if you have to watch that carefully, you will find that, especially when you are using a needle, okay, this is the, okay, let's say the surface of the water. All right, if you have to place your needle here, right, that water will be forming something like this, okay? So in a razor plate, you have to float that, okay, the razor will be, okay, let's say this is, okay, it'll be like this, okay? So we are saying that the forces of attraction between these molecules of water, that is the adhesive force, because it is the same substance, that is water. But and then Michael mentioned something on the adhesive force. So we can simply say the adhesive force between this razor plate or the particles of this razor and water molecules were the ones that hold it or cause this liquid to form like an elastic membrane, okay? And you can also do that using a needle to find it out, okay? Now moving on to the next, that is using capillary tubes, okay? Nathaniel, you have to answer that question. That is, give an explanation for your observation. What can you notice, or what did you observe from that? Okay, Joe, you tell us what you saw from that. Okay.
From my observation, I saw that a meniscus formed due to the attraction of water molecules to glass.
All right, from your observations, what it is?
I mean, a meniscus formed in the tube,
Meniscus was formed in a
glass
tube.
tube.
Those tube. Right, probably you saw that there was a meniscus which was formed in a tube. Right, we can simply say that, so there is a force of attraction between the, which molecules? Water and the tube, okay, the glass tube. So there is a force of attraction which was between those molecules. That is why a meniscus is formed. Otherwise, you would have no meniscus. The liquid will be at the same level. But you will find that this portion is force of attraction. You find that this is a meniscus. So there is a force of attraction between this liquid and also the tube. But otherwise, you should have a liquid which is at the same level. That is for water. But in mercury, you will find that it will be something like this. Okay, the mercury will be up this way. Okay. Anyway, if you have to look at that, all right, I will quickly sum that up. If you go through careful observations, you will find that the water will be rising more faster in the smallest capillary tube. Okay, it may be probably because of the area of the tube, or because it is quite small. That is the reason why the water is rising faster. However, you will see that, right, the most common concept in here is that it is rising more faster because the adhesive force between the molecules and the glass is high. That is why it is rising more faster than the capillary tubes, which has a larger hole. So you can go to that and then practice that, have a look at some of these examples later on. Anyway, to sum up what we went through, okay, for pilot teachers, you can also explain to students why this is happening or why it is not happening using the capillary tubes, and also why the meniscus is formed, especially when you are putting liquid into a measuring cylinder. And also, if you decide to float a razor blade and also the needle on surface of water, you'll find that the water will be forming something like a elastic membrane. Okay. The reason is that there is a cohesive, adhesive forces between the molecules of the substance as well as the liquid. Right, that brings us to the end of our lesson. The keyword for today would be on surface tension. Good afternoon, pilot teachers and students. Good afternoon, class.